Assalamu alaikum ma'am. Myself Torifuzzaman Riyad and we are all from Electrical and Electronics Engineering Department, and today we will be presenting on the analysis of series LC resonant circuit with resistance in parallel with inductance. This presentation is presented by Group 8 and this is the list of our group members. Contents. These are the contents that we will be discussing today. Now let's talk about the abstract. When a periodic force is applied to a system and its natural frequency is equal to or nearly equal to the frequency of the applied force, resonance is the phenomenon of increased amplitude that results. An oscillating force applied to a dynamic system at its resonance frequency causes the system to oscillate more violent. In this experiment, we analyzed a series LC resonance circuit with parallel resistance and inductance. Now let's talk about the theory. To reduce the total current at resonance, a 1 ohm resistor is connected in series with the inductor and capacitor in the following examples of series circuit. The 100 ohm resistor R2 is the additional resistance used to effect resonance frequency effects, when the inductive and capacitive reactance are equal in magnitude but 180 out of phase. The resonance of a series RLC circuit occurs. Now let's talk about the RLC resonance circuit. For resonance to occur in any circuit, it must have at least one inductor and one capacitor. The resonance of a series RLC circuit occurs when the inductive and capacitive reactance are equal in magnitude. Now let's talk about the apparatus. These are the apparatus that were used during this experiment. We have used a 10 ohm and a 100 ohm resistor. We have used variable inductor and variable capacitor. We have used an oscilloscope. We have used one function generator and 3 multimeters. We have used necessary amount of connecting wires, and to complete the simulation, NI multisim simulation software version 14.2 was used. This is all from my side. Now I am inviting my next group member to continue the presentation. Thank you, ma'am.
Assalamu alaikum ma'am. Welcome to our presentation. Thank you ma'am for giving me the opportunity. Hello ma'am. Hello everyone. My name is Muhammad Asim Iqbal, the second presenter of Group 8. Before starting our presentation, I would like to thank our first presenter Tarifuzzaman Riyad for giving his information. In this part, I will talk about circuit diagram, simulation and data table. Circuit diagram. It is a series LC resonant circuit with resistance in parallel with inductance. It is consists of one AC source, two resistor, one capacitor, and one inductor. In the circuit diagram, inductor and resistor are parallel with each other. Before starting the simulation, we have calculated a resonance frequency which is 159 Hz. Now in simulation part, we have taken required components from place and components in NI multisim 14.2 and proper labeling. At first, we have done the simulation for resonance frequency which is 159 Hz. We get the total current 49.775 milliampere and inductive current 49.775 milliampere and capacitive current 34.985 milliampere. And we can see the waveform for 159 Hz. Then we just change the frequency for 50 Hz, 100 Hz, 250 Hz and 300 Hz for 5 times and fill up the data table 1 resonance by varying frequency. Then we have varied inductance for 0 millihenry, 20 millihenry, 40 millihenry, 60 millihenry, 80 millihenry. For 80 millihenry, we get total current 36.321 milliampere. Inductive current 36.321 milliampere and capacitive current 6.99 milliampere, and we can see the waveform for 80 millihenry. We have done this for 5 times and fill up the data table to resonance by varying inductance. Finally, we have varied capacitance for 10 microfarad, 20 microfarad, 70 microfarad, 100 microfarad and 130 microfarad. For 130 microfarad, we got total current 35.497 milliampere, inductive current 35.497 milliampere, and capacitive current 5.509 milliampere. And we can see the waveform for 130 microfarad. We have done this for 5 times and fill up the data table free resonance by varying capacitance. Data table 1. Resonance by varying frequencies. We took different frequencies and fill up the data table by simulation. Data table 2. Resonance by varying inductance. We took different inductance and fill up the data table by simulation. Data table 3. Resonance by varying capacitance. We took different capacitance and fill up the data table by simulation. That's all from my side. Now our next group member discuss the next part of our presentation. Thank you, ma'am. Assalamu alaikum, ma'am.
Thank you to my fellow group member for letting me present my part of this presentation. I am MD Mahabub Ilahi Pradhan and I will be discussing about the graphical analysis of our simulated data and will also be talking a bit about the theoretical calculations. In here, we have graphically analyzed the varying frequency, varying inductance and varying capacitance versus their respective currents. Now in the varying frequency versus current graph, we can see the current value is the highest at the resonance frequency of 159 Hz. Now if we decrease the frequency from 159 Hz, the current decreases as well. And if we increase the frequency from 159 Hz, the current will also increase. Now as we know, the total current and the capacitive current of our circuit are the same, so they are represented combinedly by a single line in the graph, and that is why we can only see the capacitive current and the inductive current in the graph. Now let's discuss about the varying inductance versus current graph. In the graph, we can see the current value is the highest at 0 millihenry inductance, and if we increase the inductance value of our circuit, the current will decrease accordingly. Now let's talk about the varying capacitance versus current graph. From the graph, we can see the current value is the highest at 10 microfarad capacitance, and if we increase the capacitance of our circuit, the current decreases very slightly. Now let's discuss about the theoretical calculations. We have used necessary formulas to calculate the total current, inductive current and the capacitive current of our circuit theoretically. To calculate the resonance by varying frequency, we have varied the frequencies as needed, calculated the respective currents at those frequencies, and found that our theoretical calculated values are just quite similar to the simulated values. After the calculations of resonance by varying frequency, we have also calculated the resonance by varying inductance. And while doing that, we have varied the inductance as needed and found out nearly close values to the simulated current values. And finally, we have done the calculations of resonance by varying capacitance. And while calculating by varying capacitance, we have varied the capacitance value 5 times and find out nearly identical values of total current, inductive current and capacitive current of our circuit compared to the simulated values. And that is all from my part, and now I am inviting my next group member to continue the presentation. Thank you, ma'am.
Hello ma'am, Assalamu alaikum. This is MD Shihab Islam. Now I'm to talk about our presentation calculation part. At first, we are to talk about resonance frequency. At first, we need to calculate the resonance frequency Fm. We know the equation of resonance frequency Fm equal to 1 by 2 pi root over Lc, and we take the value of L and C, and we also input here and calculate the resonance frequency Fm equal to 159 Hz. Now we take all two more frequency. Uh, on is on is up for 159 Hz, on is down for 159 Hz. At first we take for 50 Hz. We need to calculate. We need to calculate here total current and current across the inductor and current across the capacitor. At first, we need to calculate the impedance, and we know the equation of impedance, and we implement this equation and we calculate the uh, value. And now we calculate total current. Total current I equal to IC. Total current I and the current across the capacitor are same. So we can say I equal to uh, the average value, the average value of the RMS voltage divided by impedance. Here, the RMS voltage 5 into 0.707, and the impedance is also included there, and that impedance has also angle, and we will get the total current 0.0127 ampere, and then we calculate it milliampere. So we can got the value 12.70 milliampere. Next, we calculate the current across the inductor, and we also know this equation and calculate this value of inductor 11.63 milliampere. Now we calculate. Now we calculate total current across inductor, current across capacitor for 159 Hz. We know the equation of impedance and implement this function, and also we include the values of ZRL and alpha ZRL, XC, and we got the impedance value Z equal to 72.36, and this angle is 43.6 degrees. Now we calculate the total current and capacitance. We know the total current and capacitance values there are same. So we got the value 48.88 milliampere. And the same way, we calculate the current across the inductor, and we got the value 34.58 milliampere. Now we calculate the total current across the inductor, current across the capacitor for 250 Hz. We know the equation of impedance, so we include the value. We include the value of ZRL and XC and R1, and we got the value of total impedance Z equal to 93.42, and this angle is 89.38 degree. Now we calculate the total current I equal to IC, and we include the value of impedance and include the value of impedance and the RMS voltage. Then got the value, the total current I equal to 37.84 milliampere, and at the same we calculate the current across the inductor, IL equal to R2 divided by XL plus R2 into I total current, and we got the value 37.84 milliampere. This is my second part. This slide we discuss resonance by varying inductance. We calculate this value resonance by varying inductance. Here we changing inductance value with and got total current and impedance and current across the inductor, current across the capacitor. At the same way, at first we take the value of inductor for L equal to 200 millihenry, and then with we convert it from inductance. We know the inductance equation, and we implement this value, and we got the result of inductance is 125.7. This angle is 90 degree, and at the same way we implement the capacity. We implement the capacitance value x equal to 1 by 25 c 1 by 2 fc, and we got the value of capacitance 15.92, and this angle is 90 degree minus 90 degree. And at next we calculate the ZRL, at next we calculate the impedance, and we got the impedance value 70.36, and at this angle is 27.79. And at the same way we calculate total current. This total current and the capacitor and this current across the capacitor are same. We got the value 50.2 milliampere, and we also got the current across the inductor. And at next we calculate we changing the inductor value. Here we check the inductor value L for 60 millihenry, and we can here again we the same way calculate inductance and capacitance value, and we also calculate the impedance value, and also we can calculate the total current across the capacitor, and current across the inductor, and got all of this value. Here we discuss the resonance of varying capacitance. Here we changing capacitance value, and without changing inductor, and without changing inductor and frequency. We take the value of XL and XC for 10 microfarad, and also we got the value of total impedance, and this value is 103.43, and this angle is 17.6. And also we calculate the current at the same way. uh, we and also we got this value 34.18 milliampere. At the same way, we calculate the current across the inductor. And now we take the capacitor value 100 microfarad, and we implement this function uh, inductance and capacitance, and we got this value inductance and capacitor value. And we also got the value of total impedance, and total current, and current across the capacitor, and current across the inductor. This slide name is data comparison. Here we comparing the data. Here we comparing simulated data with calculated data. Here we got the difference between the calculated and simulated data. At first, we calculate we calculate data for frequency. Here we take difference frequency, and we also got the different calculated and simulated data. And here we calculate the percent of error difference between the calculated data and simulated data. At first we take 50 hertz, and we got the percent of error is 1.76%. When we increase the value 100, 159, and 250, and 300 hertz, and the percent of error will also be increased. At next, we take the inductance. Here we vary the inductance. We change the inductance value, inductor value, and we also got the value of simulated and calculated data. Also got the different value of simulated and calculated data. For 0 hertz, we got different data for calculator and simulative. So we got there some percent of error. And we got the error for 0 millihenry, and 20 millihenry, 40 millihenry, and 60, 80. When increased when increased the value of inductor, and the percent of error will be increased. At for 80 millihenry, the percent of error is so much, that is 10.19%. When we take the value of capacitor for 10, 40, 70, 100, and 130, we got the calculator simulated. We got the different data for calculator simulative. Simulative value. We call there's some different from calculator and simulative data. And also here we got some percent of error. For 10 microfarad we got the percent of error 6.26. When we take a 40 microfarad we take 0.0%. That's are so much small. And when we take 100 microfarad we take more small percent of error 0.01%. Then at the same way we can calculate the percent of error for 130 microfarad 0.04%. This slide we discuss about the result analysis. We have completed all the calculation, and theoretically we have determined the total current, inductive current, and the capacitive current of the given circuit. We have used necessary formulas to calculate those values. While calculating the total current by varying frequency, we have noticed some error, as we have increased frequency, the percentage of error increased accordingly. Again, while calculating the current by varying inductance, some random percentage of error between the simulated and calculated values were found. And lastly, while calculating current by varying capacitance, we have found very small amount of error, which is negligible, and but only 10 microfarad capacitance we have found a bit noticeable amount of error, but at the end it can be said that the calculations are done with care and the values are quite similar to the simulated values. This is end of my part. Our next part discuss on it next movement. Thank you.
Assalamu alaikum, ma'am. Welcome to our presentation. Thank you, ma'am, for giving me the opportunity. Hello, ma'am. Hello, everyone. My name is Shaida Sharif Doshi, the last presenter of Group 5. Our presentation topic is analysis of series LC resonance circuit with resistance in parallel with inductor. Before starting my presentation, I would like to thank our third presenter, MD Mahabub Ilahi Pradhan, for giving his information. There are three parts in my presentation. In the part number 1, I will talk about discussion on analysis of series LC resonance circuit with resistance in parallel with inductor. This experiment aims to investigate a parallel resistance and inductance series LC resonance circuit by means of simulation and theoretical calculations. We have examined the LC resonance circuit. We have estimated the resonance frequency and the corresponding currents, as well as varied various other frequency values. The current values were calculated using the same methods for varied inductance and varying capacitance. The total current, inductive current, the capacitive current leaves were all properly determined. The NI multi-sim simulation program provided flawless circuit connections. We also obtained the identical values from the simulated circuit. Now I will talk about conclusion on analysis of series LC resonance circuit with resistance in parallel with inductor. From this experiment, we have learned a little bit about series LC resonance circuits with parallel resistance and inductance. By completing the experiment, it was also possible to determine the fundamental understanding of NI multisim simulation software. By adjusting the frequency, inductance, and capacitance, the total current of the circuit, the current across the inductor, and the current across the capacitor were accurately determined. In NI Multisim 14.2 software, we also run simulations for the LC resonance circuit. We truly scrutinized the oscilloscope results from NI Multisim. The outcomes from simulation and calculation were nearly identical. This experiment made a few frequent mistakes. In conclusion, we may state that the experiment's objective was successfully attained. At last, I will talk about references part. First reference is Robert L. Boylested, Introductory Circuit Analysis, 10th edition, 20 Hall, Newark, 2005 to 2006, p. 500 to 24. Second reference is Lab Manual and third is Lab Class. That's the end of our presentation. Thank you, ma'am. Assalamu alaikum, ma'am.